I went around my house and I found two different types of light bulbs, an LED light and an incandescent light. You might be wondering how one of them could help reverse global warming, so let me tell you how they work. LED stands for light emitting diode. Basically, a diode is a semiconductor device that is usually made up of silicon. This semiconductor sits inside the LED light and is attached to a positive leg, or an anode, and a negative leg, or cathode. There are two parts to it: the p-type semiconductor, which has positively charged holes, and the n-type semiconductor, which has electrons that are negatively charged. When an electric current passes through the anode and through the semiconductor, the holes and the electrons move towards each other and react. This creates energy in the form of photons, which emit the light that we see. Incandescent lights work a lot differently. In a standard incandescent light bulb, there's a piece of glass with a wire inside that is attached to a thin filament. When an electric current passes through the wire, it meets the filament, which will heat up and give off light. The reason that LED lights are so much better than standard incandescent lights is because they are much more energy efficient and last a lot longer. 90% of the energy used in an LED light is converted to light, and only 10% gets lost to heat. While in an incandescent light, 90% of the energy used is lost to heat, and only 10% gets converted to light. This is really inefficient and wastes a lot of energy. Also, LED lights are known to have a much longer lifespan, lasting up to 25 times that of an incandescent light. Because of this, even though LEDs have a higher upfront cost, users end up saving money because they last longer. Switching to LED lights is easy because they have standard bases, which means they can be screwed into any socket and can replace pretty much any other light bulb being currently used in houses or commercial buildings. However, according to the International Energy Agency, only about 50% of global residential lighting uses LED lights as of 2023. In the Drawdown book, it is predicted that by 2050, 90% of residential lighting will be LED, which would avoid 7.8 gigatons of carbon dioxide. It is also predicted that 82% of commercial lighting will be LED, which would avoid another 5 gigatons. Using LED lights is ranked number 33 for residential and number 44 for commercial. Here are the net costs and net savings of switching to LED by 2050. Overall, switching to LED lights is a pretty simple way to simultaneously have better lighting and help reverse global warming.
So I was going to demonstrate the different light bulbs in real life, but when I took out the incandescent light, it was so hot that I accidentally dropped it and the filament broke. But this is the LED light, and it does not get hot at all. So yeah.
Millions of farms have been abandoned. Traditional farming methods have drained soil fertility, caused erosion, reduced groundwater, and led to soil salinity from irrigation. These lands often become unprofitable and are left behind. Worldwide, between 950 million and 1.1 billion acres of farmland are deserted, with 90% of this degradation happening in the last century. Factors like climate change, desertification, and migration contribute to this issue, along with the lure of better-paying jobs. By restoring these abandoned croplands, we can provide food for a growing population and prevent further deforestation. Although degraded land can capture more carbon than fertile land, as plants pull carbon from the air and return it to the soil, abandoned farmlands also emit greenhouse gases, with cultivated soils losing 50 to 70% of their original carbon. Restoration methods can include reintroducing native plants, planting trees, and introducing regenerative farming methods. Passive restoration allows nature to recover the land over time, while active restoration is more expensive and labor-intensive, but speeds up the return to productivity, carbon capture, and ecosystem services. Restored soils could absorb 88 to 110 billion tons of carbon, improving fertility, biodiversity, and water cycles. By 2050, around 424 million acres could be restored or converted to regenerative agriculture, reducing carbon dioxide by 14.1 gigatons and generating a $1.3 trillion return on a $72 billion investment. Generative agriculture includes no-tilling, the use of diverse cover crops, minimizing pesticides and other chemicals, and rotating multiple crops. The goal is to rebuild soil health by increasing its carbon, which increases plant health, nutrition, and productivity. Regenerative farmers plant cover crops with diverse species, enriching soil nutrition and biodiversity. Furthermore, Adding crop rotation and intercropping prevent pest issues and improve soil health. By 2050, regenerative agriculture could cover 1 billion acres, cutting carbon dioxide by 23.2 gigatons and have a $1.9 trillion return on a $57 billion investment. Farmland restoration and regenerative agriculture offer a path to a sustainable future. Restoring our soils and ecosystem can feed the world and fight climate change.
By integrating photovoltaic cells into highways and smart grids in present day and future societies, we can promise a reduction in climate change as much more energy can be saved and reused. The U.S. National Highway System contains 160,000 miles of asphalt partially made of petroleum, which is also a fossil fuel. When vehicles go over the asphalt, they burn the petroleum, producing nitrogen and carbon oxides, which cause pollution. Currently, around 5,500 tons of carbon dioxide are emitted on 1 mile of highway each year. Companies like The Ray are creating highways made of PV cells since roads are exposed to the sun 90% of the time. This removes the need for asphalt while generating energy that can be used elsewhere. Photovoltaic cells are made up of joined N and P-type semiconductors called a p-n junction. Electrons move to the p-type side semiconductor and holes move to the n-type side semiconductor. When the sun shines on a PV cell, photons with electromagnetic radiation and the right wavelength transfer energy to the electrons in the semiconductors, making them jump to a higher energy state. This creates the conduction band, where electrons have enough energy to move freely, creating an electric current. Most semiconductor devices are made of silicone, as it can be flexible and film-like or brittle and crystal-like. However, they are also reflective, meaning an anti-reflective coating is used to cover the PV cell to maximize the amount of energy saved. Creating these new roads also means more energy features can be added to them, like snow melting devices, safer car stops, and charging for electric vehicles as they drive on the highway. Now it's time to talk about smart grids, which are another form of an upcoming way to save energy. Currently, most energy flows one way, from power plants producing electricity to transmission lines that carry them to distribution networks that then transfer them to buildings for people's use. With the help of solar panels and the internet, smart grids will be able to send energy both ways between suppliers and consumers, saving energy overall. By 2050, 0.7 to 2.1 gigatons of CO2 emissions could be reduced. With the help of PV cells, we can make smart grids and highways to save a considerable amount of energy and decrease the need to burn fossil fuels that ruin our planet.
Industrial hemp is an environmentally friendly alternative to many products we use daily. Hemp is a part of the cannabis plant and contains much less tetrahydrocannabinol, or THC, than marijuana. THC is a psychoactive component of the cannabis plant. Hemp contains 0.3% or less of it, whereas marijuana contains much more, usually 3 to 15%. Therefore, hemp is safe to use, and people have already been doing so for centuries. For example, the colonists in this photo are processing hemp to later use it in clothing. Today, hemp is harvested, cleaned, dried, then processed in different ways for different uses. For example, when hemp is being produced for clothing, it goes through retting, which is when the long fibers of cannabis are separated from the main plant, spinning, weaving, softening, then dyeing and distribution. Hemp is a very environmentally friendly material. 100 acres of hemp can reduce the amount of carbon dioxide in the atmosphere by up to 22 tons a year. Also, hemp has the potential to be economically advantageous, with production expenses of $286 and a net return of up to $473 per acre. More evidence of hemp's economic benefits is seen with the fact that the hemp industry is predicted to value $26.6 billion by 2025. In contrast, in 2022, the market was valued at $6 billion, so this is a very rapidly growing industry. With both environmental and economic benefits, industrial hemp should be used more often in production of everyday products. Hemp has a wide range of uses and can create items from clothing to paper. Overall, industrial hemp is an environmentally and economically friendly material that should be used much more frequently.
Hello class, I'll be talking about onshore and offshore wind turbines today. I'll cover what it is, how it works, the ranking, carbon dioxide reduction, costs and savings, and challenges. So, wind turbines are large structures generally composed of steel or other metals. Though the process of constructing wind turbines both onshore and offshore does result in carbon emissions, this amount is relatively small compared to the amount avoided by using wind energy instead of fossil fuels. Wind turbines provide a renewable and sustainable source of energy and can come in the form of horizontal and vertical axis turbines and onshore and offshore turbines. Horizontal axis turbines are more efficient, but vertical ones are easier to install. Onshore turbines are wind turbines situated on land, and offshore are ones built on shallow bodies of water. So, how does it work? The turbine uses the kinetic energy of natural wind to convert it into mechanical energy to generate electricity. It does this by using propeller-like blades which rotate around the rotor to capture the wind power, creating lift like airplanes. The rotor is connected to a generator through a shaft which converts the rotational mechanical energy into electrical energy. As for the ranking, costs, and savings, wind is currently the largest renewable energy source in the U.S., providing 10.1% of the country's electricity, and onshore wind turbines are ranked the second best energy source by 2050. It is also predicted that onshore wind turbines will have a net cost of $1.23 trillion and net savings of $7.4 trillion by that time. On the other hand, offshore wind turbines are ranked as the 22nd best source of energy by 2050, with a net cost of $545.3 billion and net savings of $762.5 billion. Bloomberg estimated that even by 2030, wind energy will be the lowest cost energy source, neglecting fossil fuels, that is. Moreover, onshore and offshore wind turbines are expected to reduce 84.6 and 15.2 gigatons of carbon dioxide by 2050, respectively. Recent studies have shown that wind power helps prevent 336 million metric tons of carbon dioxide emissions annually, which equates to 73 million cars worth of emissions. Wind turbines are able to reduce carbon dioxide emissions since the main idea of it is to generate electricity without burning fossil fuels, the main contributor to carbon emissions and climate change. However, wind is not the most reliable due to its variability and also its lifespan of 20 to 25 years before being dismantled, a process that releases carbon dioxide into the atmosphere. To conclude, despite its variability and minimal carbon footprint, onshore and offshore wind turbines are an extremely efficient and sustainable energy source that requires low operating costs, provides a high energy return on investment, and offers numerous environmental benefits by eliminating the reliance on fossil fuels. And here is my bibliography.
This is Johnny the raccoon. His favorite thing to do is hunt for nuts. In 2019, he went into an electric box in Illinois to find some late-night snacks. He ended up breaking the electric box and later caused a blackout for 10,000 humans. Blackouts and their causes. Blackouts occur often due to various reasons, such as wildfires and storms. Over the last 50 years, the number of power outages caused by weather has increased and is expected to worsen due to climate change. Our current energy system is fragile, but there are ways to make it more resilient. The existing energy system is highly centralized. Power plants generate electricity from various sources like fossil fuels, wind, and solar energy. This electricity is then distributed to thousands, if not millions, of customers. This centralization means that a single event, like tree falling on power lines or a storm, can disrupt power for a large number of people. Such issues can significantly impact lives, as seen after Hurricane Maria in Puerto Rico, where a blackout lasted for months and resulted in thousands of deaths. There are ways to mitigate the impact of power outages. For example, like home generators, solar panels, microgrids, where certain places have small, self-sustaining power plants, like NYU during Hurricane Sandy in 2012, which kept the campus lit while most of downtown Manhattan was dark. A local community may have several energy sources linked together to form a mini power grid. This grid can connect to the larger electricity network or function autonomously, similar to a self-sufficient power island. This approach is especially beneficial for communities in areas relying on long power lines that are vulnerable to environmental factors like wind and falling trees. Microgrids provide a more dependable and localized power supply. They can harness local renewable energy sources such as solar and wind and include backup batteries and generators to power homes and businesses in the area. Benefits of microgrids. Microgrids can generate power using green sources like wind and solar energy. It could store energy when it's no longer sunny or windy, allowing them to supply power during shortages. It could enhance sustainability by maximizing the use of renewable energy and minimizing fossil fuel consumption. Microgrids can help reduce greenhouse gas emissions. And lastly, it could support the main grid by sharing stored energy back into the main grid when needed. In summary, while blackouts are becoming more frequent and severe due to climate change, microgrids offer a promising solution to create a more resilient and sustainable energy system.
To be more civil than before. The technique developed to increase efficiency in planting. However, we soon realized that Mother Earth has been damaged. Before coming up with new ideas like new materials and genetically modified plants, why don't we give a glance at before all this get back to green talk starts, how do people manage their lands? To begin with, learning from indigenous people's land management is necessary since it protects the environment. Indigenous communities safeguard 80% of the world's remaining biodiversity, and forests on their land are better maintained. Nearly half of the world's endangered mammals live on land owned and protected by indigenous people. In many countries, the richness of animal and plant life found on indigenous people's land is comparable to protected nature reserves. The Forum report says the success of indigenous people is not coming from nowhere. It was proved by scientific data. Globally, indigenous people manage nearly 300 billion tons of carbon stored above and below ground, equal to more than 30 years' worth of global emissions. After talking about how important indigenous culture protects the environment, let me introduce some specific methods. The first common use technique is terracing. Terracing creates flat planting beds in hilly terrain. Taming the steep slopes slows runoff, allowing water to seep into beds and curb erosion. It can create more space to grow plants, even on the mountains. Another method is companion planting. Minimize pest damage and produce crops efficiently, such as tall ones company with short ones, corn and cabbage, or plants that repel each other's pests, carrots and onions. In fact, onions are great companion planting. That is because the sulfur compounds with low odor threshold are the most important factor that lead to a unique aroma of onions. Such chemical can effectively prevent pests. People can also plant crops in an order that changes from different families, so the soil doesn't accumulate pest or disease for the same crop. Another way to maintain certain amount of nutrition in soil is to move from land to land to give time for the soil to accumulate nutrients, which is called sweeten. In summary, indigenous people's planting technique might not be applicable to large scale of crop production, but its major philosophy is worth learning. Humans are part of nature, and we should adapt to it, live with it, and be involved in it to benefit other creatures as well, instead of trying to manipulate the land which feeds us.
Our rivers, soils, and even our bloodstreams are increasingly infiltrated by a group of hazardous chemicals persistent in the environment for thousands of years, PFASs. Per- and polyfluoroalkyl substances, commonly known as PFAS, are a group of man-made chemicals that include PFOA, PFOS, and many others. PFASs are notable for their long chain of carbon-fluorine bonds, which make them incredibly durable. These synthetic substances have been used in various industries around the globe since the 1940s. You can find them in non-stick cookware, water-repellent clothing, stain-resistant fabrics, and even in fast food wrapping paper because of their oil, grease, and water repellent properties. However, because of their durability, PFASs have a troubling environmental legacy. They leach into the soil and water systems, spreading far and wide. Contaminated water sources lead to bioaccumulation, the process of chemicals accumulating in an organism at a rate that exceeds the rate of excretion, affecting entire ecosystems. PFASs are also extremely prevalent in drinking water. The above map shows water treatment plants that have detected PFAS contamination. Exposure to PFASs is linked to various adverse health effects in humans, including changes in liver enzymes, increased risk of kidney or testicular cancer, and increased cholesterol levels. There are several ways to attempt to get rid of PFASs, but they are all very energy intensive. Deputy Director of Defend Our Health in Maine, Patrick McCroy, told CBS News they're practically indestructible. You can't get rid of them. To avoid contributing to the ongoing ecological and public health disaster, you, the individual consumer, can avoid buying nonstick pans or buy products without PFASs, many of which advertise this fact. Regulations to control the production and use of PFASs are also necessary. However, there is still a question on what to do with the PFAS contaminants still in the environment. One proposed solution is to incinerate them. However, this does not destroy the molecule and just releases it into the air, later to be breathed in. Another proposed solution is to dump them in landfills. However, this means that the PFASs can leach into the soil and create more problems. Recently, researchers at Northwestern have proposed an easier pathway to break down PFASs, using two relatively harmless chemicals, sodium sulfoxide, or lye, and dimethyl sulfoxide. This new method offers a promising potential solution to the PFASs already in the environment.
Trains. Trains are a series of railroad cars moved as a unit by a locomotive or by integral motors. Some trains are used for freight, while others are used for passengers. Here we're not going to talk about freight trains, not as much, because while yes, they do contribute to carbon and how the emissions, we're mostly going to be talking about passenger trains and high-speed rail because here I'm trying to make a point about public transportation. So, by statistics, I mean the drawdown book, show that trains have steadily improved the use of fuel between recent decades, like between 1975 and 2013. Energy consumption declined by 63% for passenger rail and 48% for freight services. And the train emissions dropped by 60% and 38% for both passenger and freight, respectively. And while in 2013, rail was responsible for 3.5% of emissions, in 1984, the bullet train was made, and with the founding of bullet trains and high-speed rail, which run on electricity, there have been a much less amount of fuel used, and now high-speed rail is like 20% of the global train market. According to this graph, courtesy of Our World in Data, which form of transport has the smallest carbon footprint? National Rail emits 35 grams of carbon footprint of travel per kilometer, compared to a domestic flight, which costs 246 grams, diesel cars and petrol cars that cost 171 and 170 respectively, and the only forms of transportation that stay below national rail are other forms of trains and walking and biking. Looking at the graph, you can see that the lowest form of carbon footprint of travel is the Eurostar, which only emits 4 grams. And the Eurostar is a form of cross-country train that goes from multiple countries throughout Europe to Paris. Thank you for listening to my presentation about trains.
Hello, I'm Nicholas. I'm going to be talking about the impact of transportation, specifically trucks, airplanes, and boats. For boats, 80% of global trade floats, and there are approximately 90,000 commercial vessels, tankers, bulk drug carriers, and container ships in use. Emissions from these ships are extra harmful because the carbon dioxide that escapes or exhaust is promptly absorbed by seawater, and over time, this can change the pH of the ocean, a phenomenon called ocean acidification. In this process, CO2 reacts with water molecules to form carbonic acid, and this compound then breaks down into hydrogen ion and bicarbonate. These hydrogen ions ultimately decrease the seawater pH, which is very, very harmful to marine life like lobsters, shrimp, coral reefs that rely on shells and exoskeletons to live. For trucks convey nearly 70% of all domestic freight tonnage, and 50 billion diesel is consumed every single year. Carbon dioxide and nitrogen oxides are the two main pollutant gases from automobile emissions, and even though nitric oxide is often produced as a byproduct in greater quantities compared to nitrogen dioxide, nitric oxide can quite easily react with atmospheric oxygen to form nitrogen dioxide, which can cause a range of environmental and health issues, and if breathed in, it can cause inflammation, coughing, wheezing, and other health issues. Nitrogen dioxide can also react in the atmosphere to form ground-level ozone, and can have similar effects to ozone as nitrogen dioxide, which can damage crops and also act as a potent greenhouse gas. For solutions, boats can have ducktails, which can essentially modify the water trail around the boat, which can make the boat travel through the water faster, and compressed air pump through the bottom of the hull to create bubbles that lubricate passage, which both these processes ultimately increase the fuel efficiency because it allows the boat to move faster, and it reduces fuel use by 70-22%. For trucks, fuel efficiency standards for heavy-duty trucks can be used, and continued innovation and adoption of fuel efficiency technologies can be further implemented. For airplanes emit approximately 47 times more carbon dioxide to transport the same distance as boats, and EPA reports that commercial airplanes and large business jets contribute 10% of U.S. transportation emissions and accounts for 3% of the nation's total greenhouse gas. One product of jet fuel exhaust is water vapors, which makes up about 30% of jet fuel exhaust and has a minimum direct warming impact due to its short lifespan in the atmosphere. However, it indirectly contributes to climate change by forming contrails. In cold and humid conditions, the water vapor in jet exhaust freezes around particulates, creating ice crystals that form contrails, and these contrails can spread and persist, forming contrail-induced cirrus clouds that trap infrared radiation, leading to a warming effect up to 3 times greater than carbon dioxide. Despite their short lifespan, this effect of these clouds from many flights significantly contribute to global warming and surpasses the impact of all carbon dioxide emissions from aircraft since the start of powered flight. This is my works cited.
Hey, AP Chemistry. So today I will be talking about conservation agriculture and managed grazing. So conservation agriculture, which I'll be calling CA for short, is a sustainable farming approach aimed at improving agricultural productivity whilst conserving natural resources and the environment. It involves a set of practices designed to enhance biodiversity, soil health, and water retention. I'll be talking about 2 factors that contribute heavily to conservation agriculture. 1. Minimum soil disturbance. This means reducing the amount of tilling or plowing done to the soil. By distributing the soil less, the structure is preserved, which prevents erosion, retains moisture better, and maintains the habitat for beneficial organisms. Overall, it's about leaving the soil as undisturbed as possible to keep it healthy and productive. 2. Crop rotation. This is the practice of growing different types of crops in the same area across different seasons or years. By changing the crops planted, it helps improve soil fertility, reducing pests and diseases, and preventing soil depletion. Each crop contributes differently to the nutrients in the soil and has different root structures, which helps maintain the soil health and productivity. The rankings and results by 2050 state that it's number 16 overall and 17.35 gigatons reduced in CO2, 37.5 billion net cost, and 2.12 trillion in net savings. Something cool about conservation agriculture is that contrary to the idea that it's more labor intensive for farmers, it can actually reduce labor and input costs for farmers. The second idea I'll be talking about is managed grazing. Managed grazing is the rotational grazing where livestock are moved between different pasture areas to allow plants in previously grazed areas to recover and regrow. This method aims to induce natural grazing patterns, improve pasture health, and enhance livestock productivity. Some features of this include rotational pastures. This is when pastures are divided into smaller sections and livestock are moved frequently from pasture to another pasture. Another feature is stocking density. This is when the number of animals per pasture is managed to ensure that grazing overall in every pasture is balanced. The results and rankings by 2025 state that it's number 19 overall and 16.34 gigatons reduced in CO2. 50.5 billion is the net cost, and 735.3 billion in net savings will be accomplished. Both managed grazing and conservation agriculture are ways that we can improve our environment into becoming a better place. Thank you, and this is Inoza.
Hello, I'm Grace Inoue, and this is my presentation on the clean cook stove. Cooking with fire has been around for centuries. It makes food more safe to consume, richer, and tastier. There have been many developments with cooking. Looking into any modern household, you might find a toaster, a pressure cooker, a mandolin, etc. And there are lots of technology that have been invented to make cooking easier, more interesting, simpler, more difficult, etc. Here are some images of traditional ways of cooking over the flame. The proposed model for a clean cook stove is low emissions, high efficiency, fueled by wood, working to increase heat transfer efficiency and reduce pollutants. Now, how do these work? Clean cook stoves are fuel-burning or solar-powered household stoves that can reduce greenhouse gas emissions. They can do this by increasing ventilation, thermal efficiency, or reducing specific emissions. They're meant to replace the traditional cook stoves that burn wood, dung, or coal ineffectively and without proper ventilation. Each year, there are 4.3 million premature deaths caused from fumes, soot, and emissions released. This is more deaths than HIV and AIDS, malaria, and tuberculosis combined. These traditional practices cause 2 to 5% of greenhouse gas emissions worldwide each year, and by 2015, it's expected that 15.81 gigatons of CO2 will be reduced. The net cost will be $72.2 billion. The net savings will be $166.3 billion. The emission of pollutants such as CO2, methane, and black carbon from incomplete combustion reactions contribute to climate change. Black carbon has an ability to absorb light as heat and contributes to climate change. This absorption quality also impacts polar ice. As black carbon deposits in the Arctic, the particles cover the snow and ice, decreasing the Earth's ability to reflect the warming rays of the sun while absorbing heat and hastening the melt. The leading environmental cause of premature deaths and poor health are traditional ways of cooking. Black carbon is associated with asthma and other respiratory problems, low birth rates, heart attacks, and lung cancer. The particles are so small that they're easily inhaled. Almost 2 million deaths each year are caused by the use of indoor cook stoves worldwide. This is according to the World Health Organization. That is my project on the Clean Cook Stove Initiative.
When considering potential green sources of energy, a few ideas tend to emerge. Solar power, nuclear energy, and wind are among some of the commonly suggested ones. But thousands of meters below the ocean surface may lie a massive breakthrough in clean energy production: polymetallic nodules. Primarily of interest in the Clarion-Clipperton Zone, or CCZ, an area of ocean about 4.5 million square kilometers off the eastern coast of Hawaii, these nodules may contain the answer to many of the Earth's problems with rare earth metals. The nodules start out as tiny fragments of organic matter, perhaps a piece of seashell. Slowly, over millions of years, metals slowly form a crust around these materials, forming the nodules that each may contain over 30 different metallic elements. Trillions of these nodules populate the ocean floor in the CCZ and other areas of the world. The key to these nodules' roles as energy producers lie in their content of various rare earth metals. Today, most electric vehicles are powered by a lithium-ion battery. One key type of these batteries are nickel manganese cobalt oxide batteries, or NMC, with these oxides being crucial components in the battery's cathodes, reacting with the Li plus cation and a free electron to form a combined lithium NMC oxide. The problem comes with how these metals are obtained. The mines in which these minerals are extracted are typically extremely dangerous for workers, toxic to the surrounding environment, and produce millions of tons of mining waste. Luckily, these deep ocean nodules contain significant amounts of nickel, cobalt, and manganese. The Metals Company, a corporation that deals with seabed mining, estimates that there is enough nickel and cobalt in the CCZ's nodules to power over 4.8 billion vehicles, more than double the number of all vehicles on the road today. Assuming all gas cars would be replaced, this could save over 3.53 gigatons of CO2 each year, almost 10% of yearly carbon emissions, redefining the automobile industry with a much more ecologically friendly context. This process could even be profitable, too, as a study from MIT showed a net spending cost of $1.1 billion annually on extracting these nodules, but an annual revenue of $2.3 billion, resulting in over $1 billion profit. Unfortunately, there are some caveats in the process of nodule mining. First, this is still a very unknown topic. The potential to start harvesting these nodules was only considered quite recently, and the International Seabed Authority has yet to make a decision on how mining should proceed. This part of the ocean is also generally unknown to us. Countless undiscovered species may be living in the CCZ that could depend upon these nodules for a valid habitat, meaning their extraction could lead to irreparable damage to the ecosystem. Additionally, because the harvesting machines work like vacuums, sucking up the nodules, they also displace immense amounts of sediment that is redispersed across the seafloor, having serious potential to disturb nearby ocean life. In sum, while deep-sea nodule mining may be an opportunity to transform the vehicle industry into one much more ecologically friendly, the potentially drastic environmental effects on the ocean environment are still unknown, leaving the process in a state of limbo where the barrier of green rare earth metal production may never be breached, for better or for worse.
Mammoths, the rulers of the steppe tundra, which once was Earth's largest biome, spanning from Spain to Scandinavia, across Europe and Eurasia, and over to Canada. 20,000 to 100,000 years ago, the steppe's Kolyma River basin averaged 20,000 pounds of animal life per square kilometer of pasture, including bison, reindeer, rhinoceroses, wolves, and many others. Despite this diversity, it was the centrality and importance of mammoths alone that would cause scientists to label this ecosystem as the mammoth steppe. Over the course of 11,700 years, however, it went from a grassy abode for millions to a subpolar region with rising temperatures and extinct animals. The question is, what happened to the mammoth steppe? For a while, scientists believed that the decline of the mammoth steppe was due to climate change. But after research from scientists like Sergei Zimov, it is likely this theory was flipped. Zimov details that people 13,000 years ago hunted around 50 species of large mammals such as the mammoth to extinction. In addition, when herbivores freely roamed lands, the earth was able to sustain twice as many animals compared to after the agricultural revolution when humans started domesticating animals. This shows that the decline of the mammoth steppe has contributed to climate change, not the other way around. Without mammoths and other grazers, new dwarf trees and thorny shrubs were able to grow and replace the once grassy environment. These grazers also used to push away layers of permafrost and expose the soil underneath, cooling the earth by 3 to 4 degrees Fahrenheit. Today, permafrost covers 24% of the northern hemisphere, and when it melts, it releases carbon and methane into the atmosphere. Because of this, there is 1.4 trillion tons of carbon in the circumpolar region of the Arctic, 2 times the amount in all forests. Repopulating the steppe may appear like an impossible task, but it is actually similar to other environmental restoration practices, only on a larger scale. The main idea is that just as grazers create pastures, pastures create grazers. Therefore, grasses should be planted instead of trees in subpolar regions. Sergei Zimov also hopes to relocate grazers to the frozen mammoth steppe, but this is pricey, so Zimov wants a worldwide carbon tax to be instituted to fund this endeavor. Overall, it is humanity's own doing that has led to the downfall of the mammoth steppe and caused detrimental impacts to the environment. Today, animals are raised in ranches,
feedlots, and animal factories. Both the diverse groups of herbivores were brought back to the subpolar region of the Arctic. Permafrost melting could be prevented. This would be the single largest solution to global warming ever put in place.
Hi, I'm Minna, and today I'm going to be talking about silvopasture. So what is silvopasture? Silvopasture is an integration of grazing livestock and trees in order to benefit financially and environmentally. Silvopasture allows animals to grow on land with trees that help them grow healthier. This is very different from normal pasture because in normal pasture you do not have trees around animals. So how does silvopasture work? There are a lot of potential livestock choices. For example, we have cattle, sheep, goats, horses, turkeys, chickens, ostriches, and more. The first benefit of silvopasture is that they're going to be reduced in deforestation. That is because the livestock yield on a silvopasture plot is higher. It may curtail the need for additional pasture space and thus help avoid deforestation and subsequent carbon emissions. The second benefit of silvopasture is that trees provide shade and wind protection for animals, which makes animals become healthier. The silvopasture also brings better food, and animal health goes up, and there are going to be more production of milk, meat, and offspring. In fact, silvopasture surpasses traditional grass-only pasture by 5 to 10% more profit, and there are going to be fertile soil, which benefits trees and plant growth. Now we're going to be talking about carbon dioxide reduction. Did you know that 1/5 of greenhouse gas production is caused by livestock in the world? This can be reduced by silvopasture. 26.58 to 42.31 gigatons of carbon dioxide emissions can be reduced by silvopasture. Also, the annual carbon sequestration rate is 2.74 metric tons of carbon per hectare per year in soil and biomass. Now, how much do we need to do silvopasture, and also how much can we save from silvopasture? The first cost to implement silvopasture is $206.75 billion, and the lifetime net operational cost is $2.33 trillion. However, we can also save a lot of money from silvopasture. The financial gains from revenue diversification is 1.75 to 2.36 trillion US dollars. So now we're going to talk about the chemistry behind silvopasture. So what is the chemistry behind silvopasture? So chemistry behind silvopasture is that silvopasture sequesters carbon in both the biomass above ground and the soil below. So pastures sequester 5 to 10 times as much carbon as those of the same size that are treeless. The soil also gets fertilized as the tree grows together with animals, and this makes the grass grow healthier, which leads animals to have more food to eat. Thus, silvopasture is mutually beneficial, and this is going to cause a really great cycle between the animals and trees. Thank you. And this is Works Cited.
Excuse me, can I ask a question? Hey, excuse me, wait, no. Can I ask you an interview question?
Yeah, sure.
Who did you vote for in the 2020 presidential election, and why?
Oh, I voted for Biden because he says he believes in climate change and he's gonna fix climate change, so I'm excited to see the world become a better place.
Oh, did you check the news recently?
Oh, no. What is this?
When I checked the news, I saw reports on multiple new oil drilling projects approved by Biden, such as the Willow Project in 2022. Biden's pledge in 2020 was to not approve any more oil drilling projects on federal lands. However, when the Willow Project was approved, his pledge was broken. The Willow Project is not an extraneous action from the government either, as in recent years, more and more barrels of oil are being produced by the US per day, despite 69% of Americans stating that renewable energy should be favored over oil production. So what is causing the government to not take adequate action against climate change? In this presentation, I will be talking about the effects of lobbying on the government's response to climate change and the effect on the environment. Lobbying is defined as any attempt by individuals or private interest groups to influence the decisions of the government. Where this ties to climate change is the large amount of money spent by oil companies to lobby the government every year. You see, oil companies make more money when more oil is drilled and oil is in higher demand. Therefore, actions by the government to move towards renewable energy decreases the demand for oil, hurting companies like ExxonMobil, ConocoPhillips, and Calpine. As a result, these companies spend millions of dollars annually paying government officials, including senators, representatives, and presidents, to push back on environmental legislation. An example of this is the sharp increase of money lobbied by ConocoPhillips in 2022 before and during the approval process of the Willow Project, which likely influenced the final decision of the Biden administration to approve the project. The effects of increased oil production are diversely negative, being wildlands devastated by oil drill construction, potential oil spills ruining marine ecosystems, and significant carbon dioxide emissions, putting out 23% of the global carbon footprint. Increased CO2 fuels global warming, with new record high temperatures seen each year. Therefore, the presence of oil lobbying in the US government has a strong impact on the US's response to climate change. Another example of lobbying worsening climate change is car companies pushing against public transportation so the demand for gasoline cars stays the same. Transportation in the US accounts for 28% of carbon emissions. In general, the government in recent years has taken large steps to reduce the effects of climate change. However, as a result of lobbying, our government is not doing as much as it could be. That's why it's important to encourage people around you to be involved in local and national elections, as while Biden has approved numerous oil projects, his administration has taken more steps to alleviate climate change than previous administrations did.
Is climate change causing a mass extinction? Overview of climate change. When we talk about climate change, we're referring to the long-term shifts in temperature and weather patterns, usually due to human activities like burning fossil fuels, industrial processes, and deforestation. These activities release greenhouse gases like carbon dioxide, methane, and nitrous oxide into the atmosphere. The reason greenhouse gases are so harmful is because they trap heat in the Earth's atmosphere through a process called the greenhouse effect. When sunlight reaches Earth, it's absorbed by the surface, and then some of it is radiated back as infrared heat, usually to go into space. But when there's more greenhouse gases, they absorb and re-emit this infrared heat, which prevents it from entering into space. This trapped heat warms the atmosphere and the Earth's surface. The impact on biodiversity it has. According to the Intergovernmental Panel on Climate Change, the global temperature has risen by about 1.2 degrees Celsius since pre-industrial times from these greenhouse gases being released. Climate change is a significant driver of biodiversity loss, and species are disappearing at an alarming rate estimated to be 1,000 times higher than the natural rate. This is due to several factors that are caused by global warming, such as habitat loss, with rising temperatures and changing precipitation patterns altering habitats, making them inhospitable for many species like coral reefs, which are a quarter of where all marine species live. In shifts in species distribution, many species migrate to cooler areas, but not all of them can move fast enough, nor can they find suitable habitats, which lead to population declines. Another major way that biodiversity is impacted by global warming is through phenological changes. This is the timing of biological events such as flowering or migration, which from global warming can be heavily impacted due to its reliance on temperature, the season. For example, early blooming due to warmer springs can lead to mismatches between plants and their pollinators, which is not good. Humans are not exempt from these impacts. Climate change poses direct and indirect threats to human health and survival. Extreme weather events, increased frequency and severity of heat waves, hurricanes, and floods are causing more deaths than ever and more displacements. The World Health Organization predicts that between the years 2030 and 2050, climate change will cause approximately 250,000 additional deaths per year for malnutrition, malaria, diarrhea, and heat stress. Another human vulnerability is food and water security. Through global warming, changing climate conditions are affecting agricultural productivity and water availability. Crop yields are declining, water sources are becoming scarcer, and this threatens the food security for millions of people, not just across the US, but everywhere. Another point is economic and social disruption. Climate-induced migration is leading to social unrest and economic challenges. areas most affected by climate change are often those least equipped to deal with its impacts. Scientific evidence. Numerous studies have shown the direct link between climate change and species extinction. For instance, a 2015 study published in Science Advances found that climate change could lead to the extinction of 16% of species if global temperatures rise by at least 4.3 degrees Celsius by 2100. Similarly, the IPCC's sixth assessment report highlights that without significant mitigation efforts, climate change will result in severe biodiversity loss and ecosystem collapse. In conclusion, climate change is indeed a driving force behind the current mass extinction crisis with profound implications for human survival. The scientific evidence is clear. If we don't take urgent actions to mitigate climate change, we will continue to see the devastating impacts that we have seen on biodiversity and human populations. And I believe it is imperative that we recognize our role in this crisis and work towards a sustainable solution to ensure a livable planet for future generations and for the biodiversity we already have.
Thank you.